Good morning, everybody. I'm Alain Kassab. I'm a member of the faculty in Mechanical and Aerospace Engineering. And today, Michael asked me to do a bit of an overview of the BME program, Biomedical Engineering program at our college, the College of Engineering and Computer Science at UCF. And this thing is not, sorry. So just a little bit about myself. I earned my Ph.D. in 1989 at University of Florida. I joined UCF in 1991. I was graduate coordinator for about 15 years in the Mechanical and Aerospace Engineering Department with two stints between 94 and 2003. I'm currently director of the BME program in the department, and I co-direct the MEDD program with Bill Self, and I'll discuss this shortly. I've taught a variety of courses in heat transfer, fluid mechanics at the undergraduate level, and computational and applied mathematics and numerical heat transfer at the graduate level. In engineering, my research interests are in computational methods, inverse problems, boundary element methods, and meshless techniques. And in bioengineering, I am working in cardiovascular applications of CFD, for treatment planning for congenital heart disease. I work closely with surgeons who are interested in understanding certain variations of operations that they carry out, and also applications to LVADs. And I'm a member of ASME and AIMBE as a fellow, and I edit a journal and associate editor of several journals. So let's get on with the topic at hand here. BME, so what's bioengineering versus biomedical engineering? Most BME programs have both components in them, but here at UCF, since I'm introducing the program, I thought I'd make the distinction, which arose from historical reasons as to how these programs developed at the university. So in advance of the coming of what we were hoping to be a medical school, the university developed the biomedical life sciences aspect of the field, which is bioengineering, at the Burnett School of Biomedical Sciences. So there, tissue engineering, mRNA, technologies, etc. The life sciences aspects is research is carried out and education is carried out. Engineering-based aspects of BME, which is biomedical engineering, is now the purview of the College of Engineering. So here we work on rehabilitation, prosthetics, treatment planning, such as what I've just described. And both our masters in BME and Ph.D. in BME programs are predominantly engineering-based. From the curriculum point of view, as well as the research portfolio of our faculty. All right, so why is this thing not going forward? All right, so a little bit about the components of our program. We launched a minor back in 2011. It's available to all engineering and computer science students. Essentially, that covers the life sciences training that our students don't have, some courses in bioengineering, biomedical engineering, and an externship. And recently in 2019, we worked with Bill Self and created the minor, BME minor, that is the image of ours for Burnett School, where their students take foundations in engineering courses. So, you know, the mathematics sequence, statics, dynamics, etc. And then biomedical engineering classes and an externship. And so that prepares these students to come into our program at the graduate level. Another option at the undergraduate level is a medical engineering dual degree program, which is a dual degree earned in the College of Engineering and earned in biomedical sciences at the Burnett School of Biomedical Sciences. For students, it's an elite program for students that are admitted into the college, into the Burnett School of Biomedical Sciences. So into the Burnett School of Honors College, sorry. So you have to be an honors student in the Honors College, and then you apply to this program and you earn both degrees. And so we work this out in terms of accepting each other's technical electives. And this has the advantage or the attraction for these students that they will obtain an interview at the College of Medicine if they satisfy all the requirements of the College of Medicine at the time of graduation, which we well expect all these students to do so. At the graduate level, we launched a master's in BME in 2016, and we just recently were approved and launched our Ph.D. in biomedical engineering in the fall of 2022. These degrees, the MS and the Ph.D., are part of our graduate offering in the mechanical and aerospace engineering department. We're a rather large department with about 4,500 students, 600 of whom are graduate students. And so in addition to the master's in aero and in mechanical, we offer the master's in BME. We've got a steady state level of about 25 students in the program since the start in 2016. In our PhD program, believe it or not, we had a 2-week window in which it was open for applications, and we took on 2 PhD students in the program, and we're trying to transfer some of our current PhD students who are doing BME research and who have taken the qualifying exam and the candidacy, et cetera, or at whatever levels they're at, into the BME program with the help of the graduate college. At the master's level, we have 2 tracks, biofluids and biomechanics, and listed here are typical courses. Continuum biomechanics required of all of our students. These 2 courses in biostructures that are taught in collaboration with the College of Medicine, or students actually go to the College of Medicine's anatomy lab and experience anatomy. They're exposed to anatomy lessons and dissections and actually participate in hands-on experiences at the anatomy lab, in addition to anatomy and physiology components of the class that are taught in terms of live lectures. And so depending on whether the students go this route or this route, there are a variety of additional core courses that they take. There are common courses such as bioinstrumentation, topics in BME beyond these core that are taken by both disciplines. And we also have a master's in BME MD track for students that are in the medical school at the College of Medicine who can pursue such a degree as well in parallel with their medical education. And we worked out the schedule with the College of Medicine. The PhD program itself is 72 hours. It's a standard degree that is compatible with the requirements of the University of Central Florida. There are 7 core courses that are required of the students. So the mechanics of biostructures, bioinstrumentation, topics of BME, continuum biomechanics, all of which are required for the master's. Modeling techniques and methodologies in bioengineering, the statistics class, and then they take 36 elective technical hours. And we have a variety of BME courses in addition to what's listed here, and other courses throughout the university that are germane, such as biomaterials, et cetera, that students can pick from. And then dissertation hours. So in addition to maintaining a 3.0 or better, these students must complete a qualifying exam in BME. We've launched this in our department, so since 2017, our students have been taking this option for those that are involved in BME research. It's proposal-based qualifying examination, and it's been doing very well, and we've successfully administered that. And then, of course, there's a candidacy exam, which is defense of the dissertation topic, defense of the dissertation, and our department requires an additional 4 0-credit hours of MAE seminars for our students. We admit students that have a bachelor's in mechanical, a bachelor's in BME, a master's in BME, or a master's in mechanical, or a closely related discipline who meet the program prerequisites, which are listed here. So we expect all of our students to have taken the math sequence through differential equations and additionally a programming language, and students to have picked at least 3 of the following areas in terms of their background. So if we have electrical engineers, for example, there would be satisfying this requirement, mathematics, and then one of these disciplines. And so students have a bit of liberty in terms of the prerequisites that they satisfy for the PhD program to tailor these requirements to their particular research and research path. So if students don't have this kind of background, then we expect them to explain how they will meet these requirements. These courses do not count towards the graduate degree satisfaction. There are 12 of us in the department who support the research and the academic program. Listed here is a laundry list of research areas that we all are involved in. Some of us have been around for a while. Shegan Elegbusi, for example, was hired a while ago as we were thinking of this program, in particular because of his capabilities in BME research. And all of these faculty members have been hired since, I would say, the past 10 years to support the program. So we're able to deliver the curriculum within the department, and of course, with support of other departments who offer technical electives. So we can deliver the core series of technical electives that students can take, and then certainly our students can take courses that are listed in the catalog. So I didn't want to go through all the laundry of courses, etc. I'd like to highlight, a couple of our faculty members. We've been very fortunate to have fantastic faculty members that we've hired. They've all been successful and have been doing great. Helen Huang hit the ground running with an R01 and within 2 years of joining the department. She's also just won an NSF Career Award. She has this brain lab that's involved in brain-computer interface and rehabilitation, and is interested in lower body mechanics, gait, etc. Robert Stewart, who's probably the only one in our group that's really doing work at the cell level, although his interest is in cell mechanics. So he has a lab at the Burnett School of Biomedical Sciences because of his need for cell culture and such. He won an NIH multi-year grant and just won an NSF Career Award for his work on mechanotransduction and the effects of shear stress on proliferation of endothelial cells and migration of these cells with many applications. He's looking at blood barrier in the brain. He's looking at applications in diabetes, etc. And so I thought I would highlight these two faculty members as both ends of the spectrum in terms of research, and they're doing a fantastic job, very successful, and have been core members of the program, and so have many other of the 12 faculty members that I've listed. I'm just picking examples for this short period of time. So I'm happy to answer questions. I hope I gave you a bit of an overview of our program as we've been building it over the years, and we've been very grateful for the support of the dean of the university in making this a reality, as well as our friends and partners in the College of Medicine and Burnett School of Biomedical Sciences. So I'm open for questions.
Yeah, right. Thank you, Dr. Kassab. Yeah, there's a few questions in chat that I'll go ahead and get started with. So can you go back and elaborate more on the collaboration between the College of Engineering and Computer Science and the College of Medicine in regards to the biomedical educational efforts, so the MS and the Ph.D. program?
Sure. We're intimately involved in course delivery. We could not deliver biostructures 1 and 2 without the College of Medicine. We certainly don't have access or the credentials to an anatomy lab. We certainly don't have the credentials to teach the anatomy components of those courses. So since 2016, we've been delivering these courses in close collaboration with them. We're actually publishing outcomes of these classes because it's kind of novel. We're incorporating anatomy and engineering, physiology and engineering in these classes. So that's been a very good relationship. And as administrators have come and gone, we've continued this work between the College of Medicine and our program and delivering our particular program.